Hey, morning class or afternoon for you guys. Coming at you again from my room. We're going to start talking about cartilage. That's kind of the major tissue that I want to talk about today. Okay. Cartilage it's in a lot of things. It's in your ears, your nose, it's in your joints as well. It's kind of like pre-bone. That's kind of how I describe it. Uh, this shark is it's like class chondrichthyes. Basically, it's the cartilage fish. All right, they're primarily made out of cartilage. They have some calcified tissue. Bone is kind of like calcified cartilage in a way. It's a bit sturdier. But cartilage is a really strong tissue. It's pretty stable, and there's several different types. This is one of the major types of connective tissue. Remember, connective tissue kind of holds things together, but it's flexible. It provides frameworks and kind of helps for developing bone. So it's very important and protects underlying tissues, and we're going to talk about it. All right, so cartilage matrix. So remember what the matrix is. That's the stuff between cells. Okay, that's what the intercellular matrix or extracellular matrix, whatever word you hear, the matrix is between cells. All right, it's made of collagenous fibers. Those are your bacon strips. Those are your thick tissues, those thick beams almost, that really flexible rope, if you will, that's embedded in a gel-like ground substance. All right, so it has those fibers, it has those sturdy structures, and a gel-like substance. That kind of gives it a little bit of flexibility as well as a little bit of stability. All right, so it's a little bit of both. All right, chondrocytes, chondra means cartilage, and then cyte means cell, so it's a cartilage cell. All right. They occupy small members called lacunae within their matrix. All right. So if you look, you'll really see this with hyaline cartilage, I think is the easiest to see this with, but which is a type of cartilage. But if you look at this picture right here, this is a typical cartilage cell or chondrocyte. This is a chondrocyte, which is in the darker blue. And then if you look around it, all right, there's this kind of this space, this opening. This is called the lacunae. All right, this is this cavity that contains the chondrocyte. Okay, and this relies within the matrix. When you think about connective tissue, there's a lot more matrix than actual cells. A lot of these cells are creating their matrix. That's one of their major jobs, or at least a decent amount of the cells are. That's what they're primarily doing. There's always some other stuff in there, right? But primarily they're forming this matrix. Well, I kind of think about it is that I got this tape, all right, this tape in this box, right? This is a box for tape, all right? This tape ring is the chondrocyte. It is within the lacunae, which is the chamber that it resides within, okay? And this kind of helps. That's just how they are, but it kind of provides them a little bit of space, and then they'll create this matrix around them with collagenous fibers and stuff like that. So we'll kind of see this. But just think, the tape itself is the chondrocyte, and then the box or the cavity of the box is the lacunae. So it's within the lacunae. Okay. All right. So there's three types of cartilage, distinguished by their intracellular matrix. So their intracellular matrix is in between the cells, and just kind of remember that there are cells. They're always on top of one another, right? This right here is showing some epithelium. Probably some, my guess would be some simple columnar, maybe some pseudostratified columnar on top of some cartilage, right? So there's some other connective tissue below it, all right? And that might be dense connective tissue maybe. So they're always on top of each other. They're the building blocks that your body uses to make itself. All right, so first we're going to talk about hyaline cartilage. Really take a look at this right here. This kind of open chamber, right? That open chamber, that's your lacunae. And then those little darker spots, that's your actual cells. Those are your actual chondrocytes, okay? So they're within these chambers. Hyaline cartilage is pretty easy to tell. In my opinion, it's not as hard as some other ones. But if you look at it, all right, it's these little bubbles that have a cell within them, okay? and they're kind of all kind of spread out. They kind of look like marshmallows with little eyes or something. All right, but it has very fine collagenous fibers within the matrix, so they're pretty fine. You can't really see the lines. Okay, when we talk about other types of tissue, you will be able to see the lines. All right, you can't see the lines. It kind of looks like it's all one substance. This is found on the ends of bones and joints. This is you have a cartilage in your joints, and when they get worn down, they can start grinding on bone, or can lead to different types of arthritis. All right, but they kind of cushion these joints. It's called articular cartilage. All right, but this kind of cushions those joints. It's also important in the growth of bone, so I believe that hyaline cartilage is in your growth plates. All right, so this hyaline cartilage kind of develops into bone tissue, okay, in your growth plates. And we'll talk more about that with the skeletal system, but a lot of the cartilage kind of ties in with the skeletal system, so we'll talk more about that later. But like I said, this is kind of just we're getting ready for the rest of the year. This is the building blocks. These are the fundamentals. Okay. Next, we got elastic cartilage. Oh yeah, and this one will be on your practical for sure. Elastic cartilage, I don't think this one is, but it could be wrong. This contains a lot of elastic fibers. This is going to be in your ear, okay, and is more flexible than hyaline cartilage. All right, it's not as stable, but that gives it a little bit more flexibility, like your nose and your ears allows them to be more flexible. Like your ears is pretty much just a big satellite dish, all right, that kind of funnels sound from your area into your ear and into your eardrum and allows you to hear sound, right? But it's pretty flexible, and it provides a framework for the external ears, and I think the nose as well. But if you look at it, it's there's more cells, right? There's not as much matrix maybe as hyaline cartilage, all right? And you're still able to see kind of the cavities, your ciliary lacunae, and then within the lacunae, you got your chondrocytes. These are the cells, and they're creating this matrix. They are developing it, okay? So this, from here down, this would be your elastic cartilage. That's that area. And there's some other connective tissues around it. Last, we got fibrocartilage. Thinking like maybe like fiber cartilage. All right, this is a tough tissue that contains many collagenous fibers. This is pretty strong stuff. This forms the pads of your intervertebral discs. So you're putting a lot of weight on your intervertebral discs. So think about like if you do like a squat or something, you know, you're putting hundreds of pounds on your back, and it's these cartilage rings that are kind of help protecting you, and it's protecting the disc from falling in on one another. So you got to have some pretty strong stuff here, right? But you also got to be a little bit flexible, right? Hopefully, I mean, maybe you have those contortionists who can like wrap their body in a pretzel, but for the most part, it's fairly inflexible, but it's strong enough. It's kind of that sweet spot if you get a little bit of flexibility, but not too much. That's kind of what fibrocartilage is in your back, right? It's pretty strong, but it's not too strong, okay? It has many collagenous fibers. If you look at the tissue right here, it looks like you can just kind of even see like the lines in there. It almost just looks like fabric. There's so many fibers there. All right, this forms the pads or the intervertebral discs in the spinal column, right? So kind of what I'm talking about. It's strong but not too inflexible. All right. How I kind of differentiate, fibrocartilage is one of the tougher ones to differentiate on your practical. It's confused often with muscles and with dense connective tissue. The big difference is that a lot of the times with fibrocartilage, they're a bit more circular in shape. You can kind of see the lacunae, which are the circles, and then in the chondrocytes, which are the actual cells, and they kind of line up in lines, kind of between the masses of connective tissue, or not connective tissue, but collagen fibers. All right, so they kind of form lines and they're circular. Whereas I'm going to flip to dense connective tissue. There we go. This is dense connective tissue. The cells themselves are almost more flat, almost more pancake-like. All right, they're almost like lines, and it almost looks like bacon, just bacon strips that are layered on top of one another. You can see the fibers themselves; they're really thick. But these cells are almost more flat. They're flattened in between the fibers. And then fibrocartilage, they're more circular. Just generally speaking, look at them in lab. Make sure you're able to differentiate. But in my opinion, that's how you tell them apart. Also, muscle cells are going to have striations. There's going to be kind of lines that kind of run back and forth. You'll be able to see them more. When I show you pictures of muscle cells, you'll hopefully be able to see them a little bit better. Okay. We are going to finish up by talking about bone. Most connective tissue, which comes from mineral salts like calcium phosphate and calcium carbonate, right? Your mom's probably all told you, finish your milk, right? Nice strong bones. Because what does milk have? It's got calcium. It's got calcium. All right, it's kind of like chalk, kind of calcium carbonate, right? So that's kind of the same material that your bones are made out of actually. So it's mineral salts. A lot of times, if you have weak bones, it could be from a calcium or a phosphate deficiency, or a vitamin D deficiency. This supports body structures and protects important internal organs. It also forms how you move. You move because you have strong bones that kind of function as the levers and frameworks for your muscles to move. So they protect like your skull. That protects your brain, right? Thank goodness we got one of those, right? As well as thinking like your vertebrae. It protects your spinal cord. Your hips, they protect your internal reproductive organs as well as some of your digestive organs, right? So protection as well as functioning and movement. And they do other things. We'll talk more about them later. We're going to talk a little bit about tissue. It's bone tissue. You have osteocytes, which are located in small chambers called lacunae as well. So hey, remember, chondrocytes or osteocytes in this scenario, in the lacunae is still the chamber that it's within. Okay, keep on remembering that. In science, we use words more than once, but they often have similar meanings or similar ideas between why it's named that way, because it's a lot of Latin or Greek or whatever. So osteocytes, osteo means bone. Osteo, whenever you hear osteo, think of bone. And then cyte means cell. So this is bone cell. Are bone cells that are located in small chambers called lacunae, which form circles around central canals. This dark circle right here, this is a central canal. This tissue is dead. It doesn't have any doesn't have any blood vessels anymore or nerves. But in these chambers where you would find those blood vessels or those nerves and stuff like that. So there's one here. These are central canals. Whereas this whole unit is called an osteon. All right, it's almost look like a tree ring in a way. All right, but if you look at it, there's these darker little slits. These are called the lacunae, and this is where your osteocytes are going to reside within. All right, and they're going to be building and breaking down your bones. Okay, constantly. They're constantly breaking them down. They're constantly building them back up. So there are osteocytes within your lacunae, and the whole thing is called an osteon. And these little dark circles in the middle, here's one. These are called central canals. That's where you're going to have your nerves and your blood vessels. And we'll talk more about that when we get to the bones, the skeletal system. But anyway, you guys can work on your book questions to get all this down. Make sure to smash that like button. I don't think I got any likes on that last video, so I'm kind of disappointed. Anyway, smash that like button.